In this lesson, we are going to have a look at scale factors with a particular focus on area, volume, and similarity. So let's get started with the scale factors. The very first aspect being the length scale factor given by the symbol K. Right? The length scale factor can be found by going the length of the image divided by the length of the original. Right? Now, obviously, length of the image, length of the original. That tells me an information that we're having two items, one being the image, the other being the original. Now, unless and until it is clearly specified in the question, you can pick whichever one as the image and the other one as the original. Right? The way I go about it is I pick the first one as the original, the second one as the image. But again, read the questions carefully. Sometimes it is very clearly mentioned which one's the original and which one's the image. Now, the second aspect, area scale factor. Area scale factor can be found by going area of the image divided by the area of the original, right? It can also be found by squaring the length scale factor, so being k squared. Similarly, the volume scale factor can be found by going volume of image divided by the volume of original, or you can find the length scale factor and cube it, giving us k to the power of 3. Now here's a conversion chart that could be really useful when you're converting between the different sets of scale factor, right? So let us start with the length scale factor. LSF. Right, I'm going to put my area scale factor in the middle and the volume scale factor on the right hand side, right? So obviously if we are going from length scale factor to area scale factor, right, that is simply squaring the value for LSF. So LSF to the power of 2 will give us the area scale factor. Similarly, length to volume is basically just going to be cubing the answer. So length scale factor to the power of 3. Right, the reverse is applicable too. So for example, if the question's given us the area scale factor and I have to find the LSF, all I have to do is I've got to do the square root of the area scale factor, and similarly from volume back to length is going to be the cube root, so the cube root of the volume scale factor. Right, obviously as you can see, if I want to go from volume to area, I've got to do this in 2 steps. Go to length and then square the length, and that's going to get me to the area scale factor. Right, so with that chart behind us, let's just jump into some examples. So for the two similar shapes shown below, find the unknown length x. So we've got two shapes, right? We've got the length of the smaller shape, which is 2 centimeters. We're trying to find the length of the larger shape, which we've called as x. But what we notice here is we have both the area. So area for the smaller one is 10 centimeters square, and the area for the bigger one is 250 centimeters square. And like I was mentioning in the earlier part of the lesson, right, there's no mention of which one's the original and which one's the image. So I'm going to start by saying, right, let this be the original and let this be the image. Now you can do either way, right? As long as you're keeping the order consistent, that's all matters, right? So given the fact that I've got both the areas of the shapes, right, what I can do with the two areas is I can work out the area scale factor. So the area scale factor can be given by the area of the image divided by the area of the original, which in this case is 250 divided by 10, which is giving us an area scale factor of 25, right? But the subject of this question is to find the unknown length x. In order to find an unknown length, I need to get into the length scale factor scenario. Now, how do I convert area scale factor to length? All I have to do is I've got to square root the values. So the length scale factor can be found by square rooting the area scale factor, which is nothing but the square root of 25 equals 5. So the length scale factor equals 5. Now that I've worked out the length scale factor, right, let's go back to the formula for length scale factor. The length of the image divided by the length of the original. So which means 5 must be equal to the length of the image, which in this case is x, divided by the length of the original, which is equal to 2. Right, solving for x, we can multiply both sides by 2, gives us the unknown length being equal to 10 centimeters. Right, and that's how we use the scale factors to solve for unknown quantities. In this case, we've solved for unknown lengths. Alright, with that behind us, let's jump into a second question, right? So for the two similar figures shown, find the volume of the smaller cone, right? So we have two cones here, right? We've got the smaller cone. I'm just going to draw them separately just to make it easy for us, right? Which has a length of 6 centimeters. A bit. And the larger cone, which has a length of a height of 9 centimeters, right? I know the volume of the larger cone is equal to 540 centimeter cube, right? And obviously the question is to find the volume of the smaller cone, right? So I have some pieces of information given to me, right? What I can see straight away is I have the lengths of both the shapes, right? So with the two lengths, what can we find? We can find the length scale factor, right? And again, I'm going to call this the original, the first one being the original, and the second one, I'm going to make that the image, right? So with the two lengths, I can work out my length scale factor. So length scale factor equals the length of the image, which in this case is 9 centimeters, divided by the length of the original, which is equal to 6, right? Obviously 9 divided by 6 can be simplified. Both the numbers can be divided by 3, so 3 goes into 9 3 times, and 3 goes into 6 2 times. So the length scale factor is equal to 3 on 2. Now given the fact we have to find the unknown volume, what I need to do now is I need to convert my length scale factor into volume scale factor, right? Now going back to the chart, how do I do that? All I have to do is I've got to cube the length scale factor. So the volume scale factor equals the length scale factor to the power of 3, right? Which in this case is 3 over 2 to the power of 3. Right? So if you put that in your calculators, that's going to give us the volume scale factor being equal to 27 over 8. Sorry about that. So 27 over 8. Right, now let's go to the formula for volume scale factor. It's equal to the volume of the image divided by the volume of the original. Right, so I'm going to use that to find the unknown volume here. So 27 on 8 must be equal to the volume of the image, which in this case is 540, divided by the volume of the original. I don't know the volume, so I'm just going to call that as x for the moment, right? So now I need to solve this for x. Now if you're good algebraically, go ahead and solve it, or else we can also use the solve function on your CAS calculator. So I'm going to open up a calculator page, right menu, algebra, solve. 27 over 8 equals, I believe that was 540, so 540 over x. Solving this for x gives us a volume of 160 centimeter cube. So the volume x equals 160 centimeter cube. So the volume of the smaller cone equals 160 centimeter cube. Alrighty. Now let's move to a third example. Now this is a past VK exam question. So let's have a read this question. Competitors in the intermediate division of the discus use a smaller discus than the one used in the senior division, but of a similar shape. So obviously the key factor here is both the shapes are similar. The total surface area of each of the discus is given below. So they've given us the two areas, the smaller one and the large one. They've also given us the volume of the senior discus, which is the larger one. So the volume equals 1000 centimeter cube, right? The question is, what is the volume of the intermediate discus? So the volume of the intermediate discus is what's in question here. Alrighty, so we've been given the two areas. We've been asked to find the unknown volume, right? So remember the chart. From area to volume has to be done in two steps, right? So with the area scale factor, we need to work out the length scale factor, and with the length scale factor, we can then work out the volume scale factor, right? So that's what we're going to do here. So with the two areas, I can work out my area scale factor. Right, and again, I'm going to consider this as my original, and this is the image, right, as nothing's been mentioned in the question, right? So area of the image, which is 720, divided by the area of the original, which is equal to 500. Alright, from here I need to work out my length scale factor. So the length scale factor is found by going the square root of the area scale factor. So LSF equals the square root of 720 over 500. Right? Now, once we work out the length scale factor, right, so control that button there, 720 over 500, right, that gives me the length scale factor as 1.2. Now, in order to avoid any rounding errors, now which is not the case here I got the answer as 1.2, which is an exact value. So in some cases you might have a recurring decimal or a non-terminating decimal, right? What I suggest you to do in terms of finding the volume scale factor here is, instead of rounding the values and cubing, so because from here onwards I need to work out my volume scale factor, right? And volume scale factor can be found by the length scale factor to the power of 3, right? We need to avoid rounding errors as much as possible. So all I'm going to do here is I'm going to use the answer from the previous step and then cube the answer. Right, and that gives me the volume scale factor. By doing it in this particular format, right, what you can totally do here is you can avoid any rounding errors, right? So here I got 1.728, right? Now with the volume scale factor, which is given by volume of the image divided by the volume of the original. So 1.728 must be equal to the volume of the image, which is equal to 1000, divided by the volume of the original. We don't know what that is, so I'm just going to call that as x. Now again, I want to point out another rounding scenario here, right? So let's imagine this was not a terminating decimal like we have in this particular scenario. So this is what I'm going to do. I'm going to go menu, algebra, solve, right? I'm going to use the answer from the previous step, which is my volume scale factor. So that way, if you use the answer from the previous step, you're avoiding any rounding errors there. Equals 1000 over x comma x, all right, and that gives me the volume being 578.70, so 578.70 centimeter cube, which is the volume of the smaller discus in this question. Alright, now like I said to you earlier, right, using the answers from the previous step will really avoid having any rounding errors. So what I did was I've used my answer once as well as twice. I've used it 2 times here, so that way the only rounding I'm doing is to the very final answer in this question. Alright, that's going to be really critical, especially when you're dealing with a multiple choice question or even a short answer question. The rounding errors are quite significant. Right? Thank you for listening, folks, and have a wonderful day.